Yeah,
just
no,
to get a
here's
look at
yeah,
him
there's the picture of
working.
me, and yeah, we figure you might as well get a sense of where I am and who I am here. So I just want to say hi to everyone. As Gail said, my name is Julian Paris, so I'm a systems engineer and academic ambassador with JMP, and yeah, this is a really fun webinar to give. So I'm really happy you're all here to join us to hear a little bit about JMP. And before I stop sharing my webcam, I'll just introduce myself a little bit so you have a little context about how I came to JMP and what I think of JMP as sort of best used for. And so I'm actually not a statistician, I'm an experimental psychologist. And so I think of JMP, or I originally thought of JMP as the best research tool I had. JMP, as I'm sure many of you know, makes sense of really complicated data, and it helps you get into a flow with how you analyze your data. So today for this webinar, I hope you've seen some of our other webinars, so at least you have a little bit of the general background of JMP. But what I want to get into with this one is sort of how we can get the most out of JMP and use a lot of the special tools in JMP to really very quickly make sense of what are sometimes very complicated data. And so actually, let's go back to my screen. I'm going to stop sharing my webcam, and I'll actually tell you a little bit about what we're going to do today. And so you'll see my journal here, and I'll just expand this basic section. I won't be using too much of my journal, but I do want to tell you a general overview. We're going to be working with some real data, and I'll show you where we're going to get to it from. And we're going to start by what I think is always the first step with any data we're going to work with. We're going to verify data integrity. Make sure we don't have outliers that would confuse relationships. Make sure all of our columns are correctly coded. Then we're going to work to uncover some basic relationships in the data. And then after that, we're going to do some exploratory visualization. And so actually, I'm going to minimize my journal here because I want to give you a context for what we're going to do. And maybe you've had this situation occur to you like it has to me. Let's imagine we get an email. This is, let's say, from this morning, and it comes from the boss at our company. And I'll just read this to you. It says, "Hey, Julian, I'm going to need some quick analysis of current real estate data from San Francisco, Chicago, and Brooklyn. And within the hour, we're going to need something. We're going to need overall summary of prices, bedrooms, bathrooms for all those areas, analyses comparing each area in terms of price, bedroom, bathroom size, and then graphs showing all of the above, as well as any other relationships we think are interesting." And so we're going to have to make it pretty and keep it simple. And we're going to have to do this all within an hour. And so like many real-life analysis situations, we don't have an unlimited amount of time. And I hope you found that one of the great things about JMP is how much you can do really quickly. And so the point of this webinar, the point of what we're going to do in the next hour is we're going to try to get all this done, and we're going to try to package it up and give it to our boss in a way that's easily consumable. And I'm sure most of you have felt that much of your job as an analyst is not just to figure out what's happening in data, but to make it consumable by somebody who maybe doesn't have your background. All right, so let's first look at where we're going to get these data. So I'll just pull up my web browser. If you have never used Redfin is like Zillow. It's listings for real estate. But one of the neat things I came across a while ago, which is if you search in any particular area, scroll down to the bottom of this table that lists the actual prices and their characteristics, there's a data export option. So we can actually download all from particular areas. And so I actually pulled up Brooklyn, San Francisco, and Chicago and took a kind of a random place in each of those areas and clicked download all. And so we actually got CSVs for each of these different areas. And every time I do this webinar, I actually get a brand new sample. So just like you, these are going to be, or this will be the first time I'm going to see those data. And so let's actually step through those sort of challenges we have. We're going to have to come up with some summary statistics, come up with some basic relationships, and also come up with some graphs. And I have nothing on my desktop yet, so let's actually just start off. So we're going to open these files, and I'm sure with CSVs, you don't have to do anything particularly fancy. We can just select them. One thing that I know about these data that you may not know is that the Redfin exports the CSVs in kind of a nice format. They don't have any extra rows at the top or anything like that. So I'll be able to select all three and just import them. And so JMP will bring these in as three separate data sets. But we've already come across our first challenge. So in doing any comparisons among areas, we're not going to be able to leave the data in three separate JMP windows. Of course, we're going to have to bring these data into the same window. And so the first thing I want to do is just talk about our basic sort of table problem here. And one solution to this I hope you've seen is under the tables menu. We have lots of operations that let us not only subset and split and restructure a single data set, but also bring data sets together. And so the one we're going to be using today is Concatenate. And so Concatenate is all about bringing rows from many different tables together into one single table. And so let's start off with this. And if you've never seen Concatenate before, it's a pretty basic table operation. We have a list of our open data tables. Those are the three we have. The data tables to be concatenated section is where we tell JMP what tables we want to put together. I'm going to click remove here just so we have it empty. And then we have a couple of different options, and we're actually going to use one of these in particular, the create source column. But before we do anything else, let's actually just grab the 3 data sets that we have open. I'll click them into add. And because I want to show you something, I'm going to click keep dialog open, and I'm going to make this concatenation without selecting any of those other options. And you'll see what JMP does is now we have a data set of 1,310 rows, and every row is really from each of our different tables, so they just get added in the order that we added before. Now we're going to have to make comparisons among the different regions, and what you may notice is although we have city in here as a column, we don't actually have perfect data there. So sometimes San Francisco is spelled differently. Brooklyn here actually is entered a few different times. There's even different cities that I happen to capture even though I specify just Brooklyn. And so one thing I like to do whenever I do concatenations, rather than rely on there being data in the tables to identify those different tables, I actually click Create Source Column. And creating a source column means that when I create this concatenation, JMP's going to make me as my first column the actual title of the data sets I started with. And this is perfect for me because I really want to think of these as 3 different areas I'm comparing. And so now I don't have to rely on there being any column in the original data set. And so now we're closer. So let's close out these other data sets, since we're not going to need them now that we have a combined data table. And let's start off with that first topic I mentioned, so verifying data integrity. Now, there's a number of ways to go about this, and I'm going to talk to you about basically 2 sort of methods for thinking about whether your data are valid or whether they're useful. And the first way is what I would call a univariate approach, an approach to sort of checking our data that really looks at each column one at a time. And the best way to do this that I've ever found in JMP is the distribution platform. And I'm sure if you're users of JMP, you've seen this before. And so with distribution, my standard method is just taking every column that we have, put it into Y, and clicking OK. And this is a fine method as long as you don't have thousands and thousands of columns. In fact, I'm going to tell you a little trick that will be useful if you do have thousands and thousands of columns, because you wouldn't want to do it this way. We just don't want to overload our sort of the memory just to display that many distributions. Now, the handy thing about the distribution platform when it comes to sort of verifying data integrity is it also gives us a nice sense of what columns we even have and what observations we have, and which ones of these columns will actually be useful for us. And so you'll see our source table. That gives us at least an idea of how many observations we grab from each of those different regions. Sale type gives us information about what type of listing we're even talking about. Some of these aren't even houses, new construction plans, and some of these are for sale by owner, so that's interesting. We have home type as a variable. Now, interestingly, looking at categorical variables gives us a sense of whether we may want to recode some of these categories. Notice that we have split apart here single-family residences, multifamilies of different sizes, 5 and 2 to 4. We may want to think about combining the multifamily sections into just one. And then townhouses and condos, do we really want to think about those as different? I mean, that's going to be a content question, not really a statistical question. Now, often when you're pulling through your columns like this, you're going to get to columns like address, something where that's not really a valuable thing for us to even look at. And in fact, if we're going to be showing this output window to our boss later on, and I would probably want to because we want to make sure that he or she understands what type of data we have, I don't want this in here. So rather than going back to distribution, I want to make sure you know that under the red triangles, you always have the option to remove a column. And this is actually really nice because if we're creating this display for us to understand the data, but also to show the data, we might as well start cleaning it up the way we would want to before we show it. And so make sure you know that that's an option there. Now, city is a variable we looked through before. Remember I said there were problems with how people entered this. You may even see that Brooklyn has been entered in several different ways. Some people don't know how to spell Brooklyn. And some people make entry differences like this, where capitalizations are differing. Now, if we wanted to use that variable, we could go ahead and recode things. But I think for us, we're going to use that source table variable that we created. So I'm actually going to remove this as well. We have state, zip code, list price. Now, we're getting to some numeric variables. So notice that the kinds of things we need to attend to when we're thinking about whether data are valid or useful is going to change. And in fact, when we get to numeric variables, the thing that I'm looking for, of course, is outliers. And what is an outlier is sort of a difficult question to begin with. But I think from our standpoint, when it comes to creating simple reports or at least for giving people a sense of the data, An outlier for me is anything that would confuse or otherwise muddle a relationship. Something that, if you were to remove it, would actually clarify what is actually happening in whatever population we're talking about. Because notice that some of these points, here's an $18 million house. Well, that's probably a real house, or $17 million house. That's a real house, but maybe that doesn't reflect sort of the rest of the houses in that area. And so even though it's a real data point, it's not an entry error, perhaps it doesn't really convey the sense of the population. Let's leave those for a second here, because I want to scroll across and just get a sense of these numeric variables. Certainly the most important ones for us will be list price, bedrooms, and bathrooms. Now there's some interesting ones here. So there's a bathroom here with 16, or a house here with 16 bathrooms. And you'll notice that that's a pretty far departure from even the next most. So the next most here is down here at 10.5. And then we have a big clump of them right around the top of the distribution. Now, I want you to know about a feature that maybe you haven't seen before, one that I like to use when I'm cleaning data or thinking about what I may want to include or remove later on. And my standard practice is not to eliminate outliers right away. You should hopefully know that you can drag a box around these, and they'll be also selected in your data set. And so just so you can see, I'm going to go to my rows menu and go to Next Selected. So even if we simply select the observations, we can always find them in our data table. But one thing that I like to do, especially when I'm working with a lot of these columns all at once, is we can right-click, and there's an option to name a selection in a column. And I want you to see what this does, is it brings up a little panel here that we can give a label for these observations. I'm going to say this is, large number of bathrooms. And it'll create a column in the data set that has a 1 if they're currently selected and a 0 if they're not. And so I'm going to go ahead and do this because what I may want to do is think about these points later on or to investigate them later on. And by creating that new column, I now have a column that I can actually use to find those points again. The other benefit is we may want to make several overlapping criteria for exclusion. That is, if we're thinking about bathrooms being large or too many for a house maybe, we may want to consider that as a separate sort of outlying characteristic than the number of bedrooms. So there's one here with 18 bedrooms. Now that doesn't seem too far from the rest of the distribution, so I'm just going to leave it alone. Let's continue to slide across here because we may find some other interesting things. Location, right? This is sort of like city. I'm actually just going to remove that. I don't think we need to show that to the boss. Now, square footage, this is kind of interesting. We have two properties here with square footages of about 160,000, so 158,230. That's a pretty big house. So that's certainly one I'm going to make another selection set out of. So name, selection, and column. And we'll call this large square footage. So SQFT. And so this is another selection that we may want to eliminate or include. Lot size, maybe we don't want to think about too much. In fact, maybe we're not even going to talk about that with our boss, so I can remove that too. But year built and some of these other variables might be useful. Now, rather than go through all of them with you right now, I think you get the general practice here. And certainly the main point is that you can scroll through all these columns very quickly to get a sense of whether your data are entered correctly, but also whether there are observations that may end up changing relationships. And that's actually something we'll look at in the second section. My thought process is always to look at how these very influential points might change or disturb a relationship rather than simply eliminating them or excluding them. But certainly I hope you know that you can select points and exclude them right away. If you really know that they're bad data points, you can just row hide and exclude them with them selected. Now, with as many columns as I had in this data set, this process worked just fine. I was able to create this distribution output and simply scroll across. But I'm going to minimize this and show you a little trick you may not have seen. And this is very useful when you have, let's just imagine 10,000 continuous columns and you want to scroll through each of those and look at their distributions. So a nice way to do that is let's go to the distribution platform. And I'm just going to show you, I lost jump here. I'm just going to show you my standard plan for how to do this. And as I work through, you'll sort of get a sense of why I'm doing it this way. So I'm going to launch the distribution platform. And what I'm going to do is put in just one single continuous column. And remember, we're going to imagine I have a data set with, let's say, 10,000 of these. So I'll put in just one continuous column, and I get a single distribution output for that column. And what I'm going to do is invoke a column switcher. I don't know if you've seen a column switcher before, but it lives under the topmost red triangle under the script menu. And if you've been working with JMP for a while, you've probably seen the script menu. It has options for saving scripts to the data set, very useful if you're trying to make reproducible analyses. But the column switcher is a great option. What this will do is give us a little panel that allows us to switch in a different variable for list price. And if we wanted to, we can just pick one of these right now. But a useful feature in JMP is that you can pick many at a time. And so what I'm going to do is go to the red triangle, and I'm going to turn off the nominal columns, and I'm just going to select all the continuous ones. And again, imagine we're thinking of this generalizing to 10,000 different columns, but it's okay that we only have maybe 30 here. I'm going to click OK, and what I get is a panel, the column switcher panel, which now lets me simply click through or even arrow through these different columns. And the value here is very quickly, if you're just looking at these distributions, you'll be able to spot irregularities quite quickly. And in fact, if you have many, many columns all at once, you can very quickly just tab through each of these. And so what we've built ourselves is a little control panel. And this is a great way to not only look for yourself, but also show data to somebody else. The nice thing about this is it focuses their attention on just the distribution you're talking about at this moment, rather than them trying to look at all of them at once. And so the column switcher is a great little tool, and we're gonna use that later on as well. All right, so I want to point out one additional thing before we kind of leave the data integrity section. If we were to make several of these overlapping selection sets, that is the ones that identified characteristics that maybe we thought are problematic in these data, one thing you can do, of course, is click on any of the ones, right-click and do select matching. This is a nice option because what this will do is select all the ones in this column, which means that the two I had before that were kind of outlying as far as bathrooms, I can now right-click those rows and hide and exclude. It also means that we're going to be able to use this as a filter later on. But imagine you wanted to, let's say, at a large number of these overlapping selections of potentially problematic points, and you wanted to eliminate any of them, or somebody or an observation who happened to get a 1 in any of these columns. A really nice feature in JMP is the instant formulas. And what I can do is just with these two columns selected, right-click, go to New Formula column, go to Combine, and I'm going to take the maximum. And think about what this will do as a formula. If I take the maximum over a bunch of columns that have 1s and 0s, well, if there's a 1 in any of those columns, then I'll get a 1 in the final column. And so this allows me for an arbitrarily large number of overlapping selection columns to create a final selection. And so now I can right-click, select matching, and notice that I have 4 observations because some of them were large in terms of square footage, some were large in terms of bedrooms, and now potentially I have 4 that I wouldn't want to include in a final analysis. All right, so before I step forward into looking at some basic relationships, let me see if Gail has any questions on anything I've talked about so far.
Yes, we have a few. I know we're not going over row labeling, but outlier came up. Somebody questioned whether or not you automatically find outliers and get rid of them. You might want to address what you do with outliers, and the second part of that is, can you label the outliers?
Yeah. Oh, those are great questions. How to deal with an outlier is a tricky problem, and it really depends on your field. I can tell you from my scientific background, so within research, it's really problematic to exclude an outlier unless you have really good justification that the data were bad in some way. So someone answering 150 on a scale that should go 1 to 10. But typically, and I'll talk about this more in the next section, typically the nice thing to do with outliers is to consider analyses that are really valuable, things that you're actually going to run with and without those outliers, to see if they really do change a relationship or change your interpretation of those data. Now, as far as labeling them, let me actually just go back to that distribution report. One thing that I like to do with outliers, especially when I'm working with several different output windows, is we can grab a couple of them. Let's just grab this really high bedroom. And if you right-click, and you can do a lot of things. You can make its marker style a little bit different. So you can change a color, drawing mode. Let me actually give it a different marker here. So I'm going to give it a star. And the nice thing about giving it a different marker, and this is true all across JMP, that's actually going to apply it into the data table itself. And so when I go to the data table, let's go to the next selected row. Notice that it has the little star marker there. So if I go into any different output, let me actually just I'll go to a graphing output. So I'll go to Graph Builder, and let's look at, let's say, bedrooms by bathrooms. So in this output, you notice that that point is actually still marked. And the value of that is it will retain that marking in any output that can show the points. And so that's a nice way to keep them labeled. Yeah, hopefully that answers that question.
Yes. Do you have time to go over column switching really quickly? I know that's not the crux of this, but it might be
absolutely.
in context interesting to people.
I think it's a very useful thing. So let's actually look at it one more time. And I'll do it as a slightly different operation this time. So the last time I did the column switching with the numeric column. Let's do a column switcher with a categorical column. So I'll put in source table first. And you have to put in just a single column to make this work. Hit OK. And then in order to invoke the column switcher, it's under that top red triangle, which is a red triangle that applies to this whole platform. And that's where you'll find the script section. And remember, you'll always find script under really the topmost red triangle of any platform. And under there, you'll find the column switcher. And this time, since I was using a categorical column and I want to switch in another categorical column, I'll go to the little blue, red triangle here and just turn off all of those continuous measurements. That gets rid of all the numerics. And this time, I'll just grab all the categorical columns again, hit OK, and now I get this little column switcher. Again, that lets me just click through the different columns in my data set. When I get to one like address, it'll pop you down to the bottom there. But the nice thing about this is you can actually scroll through. And I will say, if you're going to make a little column switching sort of viewer, you'll want to do it separately for numeric and categorical columns. Since the types of output for each of them are different, column switcher prefers to switch in things of the same modeling type. So just be aware of that. Great.
Julian, you had a question. Concatenate was covered in detail last week, and we do have a recording of it. But someone actually wanted to see it again, but also brought something up and wanted to suggest that concatenating involves a little more than just combining the data. So was not clear that if the columns are not the same, what would happen?
Oh, that's a great question.
When you concatenate.
Yeah, concatenation is really all about merging rows together. So there's no question about, no question in JMP's mind about whether it's reconciling rows that are the same. So no matter what, if you have two tables that are 50 rows each, you're going to get a 100-row table, even if they all are the same observations. So in one sense, just know that it's about putting rows together from different tables. Now, if there are columns that are not overlapping, so columns in one table that don't exist in the other, you'll actually get all the columns from any of those tables. And so what you'll have is, let's say you take two tables that don't share any columns at all, you'll just get a data table that's twice as long as the originals, so all the rows from each data set, and you'll have all the columns from each. And since the rows in one data set didn't have any observations in the columns from the other, they'll just all be blank. And so concatenate's really about as if you were to copy and paste two tables together into one table. And so when they share columns, it's useful. But if they don't share any columns, then it's not the most useful operation. That's something where you'll probably want to consider join. And of course, if you're working with tables that share rows and are associated by some kind of key, so for instance, you have students in 4 different classes, but some of the students overlap, so you want to combine their information. Join is really where you'll want to go. That allows you to not only bind data tables in terms of rows, but also columns, and in terms of something that matches.
Thanks. And then, so basically the question was why you might not merge or update. You might want to go over what the difference to update is. Yeah,
update is really about having a table that has all the original keys. So you basically have, let's imagine with a company. So you have a customer database, and you have the biggest one, and then you ran a survey which updated some people's addresses. And so if you want to update your customer database with the new observations, let's say new addresses, update is really great. You update against a new table. So the new table provides new observations that should overwrite your existing operations. Concatenate, if you were to do that, would actually add those people from your table, the people that already exist in your original, it would actually put them right at the end of the table. So it's a very simple-minded procedure. It's not looking for whether data exists in the table already. It's simply adding the rows to the end of the table.
Thanks.
Sure.
Let me see if there's one more. I think you may have answered two in one. You got a comment. To record categorical variables, it was really fast, and the question was, did you use a script only?
I didn't recode anything, in fact, in this one yet.
Okay. So maybe if are you going to be doing any recoding, or should I point somebody
No, I might actually. I'm going to show a
webcast?
recode real quick, actually, because before we start looking at analyses, this particular column, I don't really like how this one is listed. Remember how we made this? This is when we concatenated tables, and we had jump actually just use the table names. And so this is a great time to actually talk about recode. You might remember also when we were looking at, let me go backwards here, when we were looking at the types of houses we had, so vacant land, townhouse, we might want to actually combine together some of these different groupings. And so let's actually look at the recoding facility, because it's one of the more wonderful things about JMP if you've never seen it before. And let's do it for each of these columns, and I'll actually show you different ways of how we're going to recode for each. And so recode works by first selecting a column you want to recode, and then under the columns menu, under utilities, is the recode facility. And so recode brings up a panel that in essence shows you original values and what new values you want to have. And so for this one, all we really want to do is get rid of the extra stuff at the beginning. So I'm just going to delete out all the extra text for each of these. And I'll make sure there's no extra spaces. And for San Francisco, and for Brooklyn here. Now, what this is going to do when I click Done is notice give me an option for how I want this recoding to happen. And I like to spend a little bit of time talking about this, because what you choose here really depends on what you're recoding and what consequences or really how worried you are about maybe having done it wrong. In this case, we're simply pulling out extra text from each label. We're not grouping together categories or making decisions about what things should or should not be combined. And so in place, which is an option that will write over this existing column, I think is just fine. And I only mention this because very rarely do I do an in-place recoding. The reason why is if maybe a year from now I open this table and I had made some choices about what column or what category should be combined, I wouldn't have access to the original data. I mean, I could go download it again, or hopefully I had a previously stored version, but that's why in place is a little bit risky. But when you're not combining categories, you're just correcting little errors, I think in place is just fine. So let's actually do that for this. And notice what JMP will do is now very quickly replace all those values with the values I desired. Now let's look at home type, because we're going to do something slightly differently there. So I'm going to again go to columns, I'm going to go to utilities, and go to recode. Now in this case, we actually have to make some choices about what categories we do or do not want to combine. And the way recode will work if you want to not simply just change a category but recode them is we can actually just select a couple at once. Let's say the multifamilies. I think it's pretty obvious we may want to just combine those. I can just click group. And what JMP will do is show that these two original categories now get grouped together, and we'll actually have the multifamily 2 to 4 unit label. Well, since we're actually combining them, we should take away that 2 to 4, so I'll make that a little bit cleaner. Now with townhouse and condos, I'll actually select those two as well. I'm going to click group. Notice that they get a grouping too. I'm just going to leave them called condo co-op. That's just fine. And then vacant land can stay vacant land, and single family residential can stay there. We also have some blanks here, and so blanks in our data set that were unlisted. Now in this case, I would not want to select in place, because I really did make some choices here about what I wanted to combine. And plus, I may want to retain those original values to use them in maybe some more formal analysis. And so I would select either new column or formula column. Now the difference is that new column will write these values to the data set, whereas a formula column is going to use some match logic. And that's actually my preference. I'm going to show you why. So I'm going to select formula column. And what this will do is I hit home type 2, so it gives a little extra 2 at the end so we know it's a new variable. And it actually accomplishes this recoding dynamically. If I right click and go to formula, you'll notice what JMP did is it wrote us some match logic. Match works in this way. It says, go to this variable, home type, and look for these values. And if you find these values, make them these values. And so what's kind of nice about this formula is not only that it does it dynamically. If I were to concatenate new rows to this table, it would continue to do this recoding, which is really neat. but it also gives me my recoding schema. I can actually copy and paste this out to another document and show my boss how I did the recoding. And so as far as reproducibility, as far as being very upfront about what you're doing, having the formula saved gives you a nice ability to see exactly what choices you made for your recoding. Now, this is a fairly trivial example, but when you have more complicated examples, it's very nice to be able to look this up and see what you did. And so that's probably the easiest way to do those recodings. And so that home type 2 is probably one that we'll want to use. Now, as we go forward, the next section is really about looking at relationships. And so I'm going to wrap in another idea of data quality, but also a way to look at relationships. And it's sort of the generalization of the distribution platform. And it lives under multivariate methods and multivariate. And the reason I want to talk about this is when we're looking at the really critical variables in our data set. I think they're list price, bedrooms, bathrooms, square footage. So when we're looking at those variables, what I want to really investigate is, well, first off, how do they relate to each other? We should expect certain correlations or relationships there. But also whether in multivariate space, looking at them in more than one variable at a time, do we find observations that maybe we have doubts about? So let me show you what I mean. I'm going to put these into the Y role. And multivariate doesn't require a Y and an X. It's all about looking at just the responses, but their relationships to each other. I'm going to click OK, and what we get is our multivariate scatter plots and correlation matrix. And what you're looking at here, if you've never seen a scatter plot matrix, is if we look at just this top row, the top row has list price on the Y-axis. That's what this is over here, for every one of these plots. But the X-axis is differing. The X-axis for the first one here is bedrooms. The X-axis for this one is bathrooms. And the X-axis here is square footage. So what we're looking at is little bivariate pictures of each of these different columns with each other. And if we step down to the next, we can see bedrooms on the Y-axis now with bathrooms on the X, or square footage on the X. And then finally, bathrooms against square footage. So this top triangle here, or the top half, is actually the flip of the bottom half. So depending on which you want on the X and Y, you can look at either. But basically what we're looking for here is not only what relationships we see, we can look at the correlations between each of these, but whether there are observations that don't make any sense. Now I'll give you an example of an observation that doesn't make any sense. Here is a house with what I think was 158,000 square feet. That was that one. And it's a one bedroom. That's a pretty big bedroom. So what we're looking at here is looking for bivariate outliers, outliers that are just senseless based on the relationships of our variables. So I want to show you a nice little trick here in the multivariate platform, which is under the top red triangle, outlier analysis, and it's the Mahalanobis distance. A Mahalanobis distance is a type of distance measure, but it's scaled relevant to the correlation structure in the data, which is just to say it's looking for those things that don't make sense in the context of the existing relationships. And when you produce this output, what you get is this nice little Mahalanobis distance chart. The x-axis here is just the row number, so from 0 all the way up to 1,310 rows. And the y-axis is the Mahalanobis distance. This is the scaled distance measure. And what you'll see is there's a little control line. The control line is sort of a representation of how distant should you find points in sort of this space relative to a multivariate normal. So if you had all normally distributed variables and were normally distributed jointly with each other, how far should points be from that centroid? Don't worry about that too much, but what you'll notice is that most of the points are very low. They're where they should be. And then you have points that sort of exceed that line. Then you have some that are really wonky. And so these two right here. And if I select them, let's actually give them a marker like we did before. So I'll go to row markers and let's give them a Z here. And so those observations, if we look at where they are, they're the ones that are kind of in weird places in a lot of these bivariate plots. And actually, if we want to look into these a little bit further, here's something I like to do. If you right-click on the selected section in the dataset and go to Data View, what this will do is bring out a dataset here with just those observations so we can look at these. So let's just scroll across. So these are 125,000 and 335,000. These are condos. They're one bedroom, one baths, with 158,000 square feet. Okay. And they're actually the same observations. If we look at these are duplicates now in our data set. So that's pretty weird. I don't think we think that is really reflecting something true about the population. That's a very strange observation. And so this is a situation where probably these are observations we just want to eliminate. So hide and exclude from our data set. And so this is something I might actually just do right away. But let's keep them there. I'll use the trick that we did before and actually select them, name a selection in column, and call these multivariate outliers. Just do multivariate out. And so those are kind of strange. Notice that one we started before, that's actually pretty far up here as far as an outlying point. And so that's one we actually already identified. But notice that in multivariate space, it becomes very obvious again. This is extraordinarily large house, large bathrooms, but tiny square footage, which is actually kind of strange. So actually, if we look at this, this is a 16-bedroom house with 3,500 square feet. Well, that's a lot of bathrooms for very small square footage. And so that's probably something we would want to not include as well. And so multivariate as a platform is a really useful way to look at these relationships and to really look across all the data. But let's actually get into a little bit more formula of an analysis. And this is something we can do with really the next platform from distribution, fit y by x. And fit y by x, remember, is all about looking at relationships among variables. And what's great for us is we can look at a number of relationships all at once. And I think probably the most interesting thing that we're going to be showing our boss at the end of all this is how our regions are differing in terms of these key characteristics. And so I'm going to take that source table column. Remember, that's one we recoded to be just Brooklyn, San Francisco, and Chicago. I'll put it in as my X here, and let's actually take all the variables of interest. So list price, bedrooms, bathrooms. I'll even put square footage in there. And I'll put that into the Y role. Now, Fit Y by X, I'm sure you've seen before, is a nice contextual platform. It's a platform that will give you different output depending on the type of data you put in. And so in this case, the types of analyses we're going to be looking at are really tests of means. Does the average differ from each of these different regions? And so if we just scroll through, we get our dot plots here. Notice that we have some of those observations that were a little bit wonky, so we're going to have to do something with those in a second. But what I'm going to do is produce some output for each of these. And perhaps my favorite, because I get a lot of details, is the means and ANOVA option. Now, before I select this, remember I have 4 different analyses in the same window. And if I turn on means and ANOVA for each of them, well, that's a lot of extra clicks. So I hope you know that you can hold down the Control key, then select the red triangle, then select means ANOVA. And the way JMP interprets that is to produce the same analysis for each of the different outputs. And so instead of having to actually go through and do it separately for each, we can do it all at once. The Control key click also works really well if you want to hide output. So I'm going to hold down the Control key and minimize some of this output. So I can actually minimize the whole thing or just the, let's just do actually the analysis of variance table here. And so now we can actually do that. I'm going to do it for these guys too. Now, one thing that we certainly have talked about and haven't taken into account yet is the fact that we have outliers or observations that we may want to consider or not consider. And so I'm going to do something that I think will be really useful, I think, for your own work here. Let's go back to our data set. We actually made, remember, a new outlier column. So I'm going to select the 2 we had before, plus that multivariate outlier column. And remember the trick, I'm going to right-click on the column, new formula column. I'm going to combine them, and I'm going to take the maximum. Remember what this does is it just looks across the columns, and if there's a 1 in any one of them, it'll give it a 1 in this final column. And so this final column here, I'm actually going to rename it, and I'll say outlier. And what I'm going to do is go back to my Fit Y by X window, and remember, I want to consider what these data would look like with and without those outliers. And so under the top red triangle, under script, there's an option right next to column switcher we're going to use that we haven't used before. It's called the local data filter. Now, the local data filter is what it sounds like. It's a local, or one relevant only to this window, version of the global data filter. The global data filter is under your rows menu. And so if you've never used the data filter, it's right there, data filter, which lets you create subsets or exclude and include observations based on some criteria. The local data filter applies to only this window. And what it's asking me for is a column that I want to use. I'm actually going to tell them that this column is nominal. So I just right-clicked on outlier and made it nominal. When I click add, I now get a little panel that says, do I want to look at just all the observations or maybe just the ones without outlier marked? So if I look at just the zeros, notice that my response changes. If I click on the ones, I can see what that does. Notice that it does change the observations. If I click off, now I'm only looking at the observations that haven't been marked. And so in a little panel here, I can actually switch back and forth and see the consequences it has for these different outputs. And I find that to be a really useful way to actually look at these relationships or to look at the differences. And so if I'm not considering those points that I marked as a little bit suspect, I have a nice means for the one-way ANOVA table. So means for each of the different groups. And so this is something I could potentially show. I could say, here are the means for Brooklyn, Chicago, and San Francisco, and we can see the differences there. If you want to change the axes, remember you can always click and drag. With list price, this is something where maybe I want to put it on a different scale. So if you double click, you may remember that the scale types can be changed. This is one where, maybe we want to make it a log scale. This way the differences are a little bit less spread out. We have distributions that are so wide here that, in log space, this actually becomes a little easier to look at. But certainly we see that San Francisco is the highest here, Chicago, then Brooklyn. So again, this little outlier trick, that was using the local data filter, a nice way to filter in or out the points that you had selected before. And if we scroll down, we may want to, clean this output up a little bit. We could even remove sections, but I kind of like this panel because, again, if I'm showing these data, I may get the question, well, which outliers did you take out and what would happen if you hadn't taken them out? And so I like being able to have that all in one window. Now, another type of analysis we may be interested in, I'm just going to minimize this one. Another analysis that I would want to show anyone I'm showing these data to is sort of what the value is of maybe each additional bedroom. And so if I go back to fit y by x, I want to show you a trick you may not have seen, and especially useful when you're working with continuous columns. And so if we're looking at, let's say, the list price as a function of bedrooms, so this is going to be a different type of fit y by x output. This is the bivariate. So when we have two numeric columns, you might remember that you can always fit a line, and this line will be fit across all the data. Right, so this line is actually going to show me the average, sort of how much additional sort of price you get per bedroom. So if I minimize some of this extra output, let's just look at the function. So we have an intercept, how much it costs us to get a house with 0 bedrooms, effectively, plus, on average, $263,000 per bedroom. Well, that's the average across all the different regions. Now, what if you wanted this separated for the regions? Well, I want to show you two ways. The way you've probably done it before, I'm guessing anyway. Let's go back to Analyze, go back to Fit Y by X. I'll hit Recall. I'm guessing you've used the bivariable. And when you do a bivariable, you can actually feed it the source table column. And this tells JMP, split up the analysis on top based on the levels of whatever you use in the bivariable section. So this is one way to do this. Now I want you to see what will happen. I can go in, hold down the Control key first. Remember that lets me broadcast a command. I'll fit a line. And we're going to get a lot of output here. And notice that we actually get one output for each of the different regions, which is a perfectly fine way to do this. But that's actually not the visual I would want to show. In fact, what I would rather do, and I'll go back to the left-hand side here, is I'm going to select the red triangle, and I'm going to select the Group By option. And this lets me specify a column I want to group by. And let's see what happens. I'm going to select Source Table, hit OK. And then I'm going to go and fit a line again. I already fit a line, but when I invoke this command this time that I have Group By checked, it's actually going to produce for me the lines on all one plot. Let me go back and I'll remove the original fit. So I removed the one that I actually fit that first time. Now we actually get kind of an interesting visual. Instead of looking at these across different plots, which frankly to me doesn't give me a lot of ability to see the different relationships. I'm just going to close this. Over on the left, we actually can see different slopes. So basically for Brooklyn, the cost of an additional bedroom seems to be very trivial, but the cost of additional bedrooms in San Francisco a little bit less than Chicago. So it costs us a lot for every additional bedroom there. And if we hide all this extra output, we'll actually be able to see for each of these the actual cost of an additional bedroom. So Brooklyn being $154,000, Chicago being almost $1 million per bedroom additional, and San Francisco $541,000. But you might remember that these analyses are still including some of the suspicious points. So let's do that trick I did last time. I'll go to Script, go to Local Data Filter. I'm going to tell it I want to filter on that outlier column I just made. And let's just look at the ones that aren't included as an outlier. Okay, so it stayed pretty consistent. In fact, if I toggle on the outliers, so the way I'm doing this is holding that Control key to click and add or click off, notice that it's not changing the relationships much. I can feel pretty comfortable that I haven't just made a relationship up because I excluded points, as this, at least for me, is something that I would always want to see. And so do notice that you can use that group by section. This is a great option, especially when you have analyses that you want to show, especially regressions like this, across the levels of different variables. So that lets you really profile those. Yeah, so I'm going to stop there before we play a little bit in Graph Builder. Gail, do we have any questions from this last section?
Julian, you've had a few, and I'm trying to answer them on our own. You don't have to show it. Just one reminder to everybody. If you use Recode, you can save that Recode information to a column, and then if you update that table, the information that comes in will be, you'll be able to have it all recoded. Correct, Julian?
That's correct. And that's the wonderful thing about saving the formula. Since that formula is always processing, as soon as you add in new values, it'll continue to recode. Absolutely.
Okay. And then the other thing somebody asked, if the source is saved. Yes, in the source, if you were to right-click and go edit, you will see the script, which will have the full location to where you went on your Internet Open and found that data file. So I will try to give those instructions also in the email that goes out. You have a question about scatterplot matrix. Is it possible to color points differently for different cities? That's a general question.
Oh, that's actually a really great question. And this is something we would do in the table itself. You could do it later on, but here's the way to do it. Under the rows menu, color or mark by column is a wonderful thing. And I always forget to show this one because it's actually very, very useful though. When you go to color or mark by column, JMP will ask you basically what column do you want to use to color or mark by. Select source table, and then you get to choose your color scheme. We'll just leave it on the JMP defaults. And what it's going to do when I click OK is actually apply a row state, so the coloring row state. So now, no matter which platform I go into, so let's go back into multivariate and recall what I did before, now we actually have them all colored and marked. So a really nice thing, especially when you have very few categories that sort of are distinguishing themselves. So we only have 3 here, and so it makes it very easy for us to really spot those differences. And so, yeah, again, that's under the rows menu, and this will then apply to any output you have. Great question.
Thanks. I'll let you continue. And just a reminder, Julian has a very short time to go over Graph Builder. I will also send everybody a link to the next live session on Graph Builder, which will be only about Graph Builder. Thanks, Julian.
Yeah, definitely. And certainly attend that Mastering JMP on Graph Builder. There's so much to talk about here, but I want to point out just a couple of really useful things that we'll be able to do. And remember that Graph Builder, if you haven't used it, I started with JMP about a decade ago, and we only had chart and some other options. Graph Builder was added in, a couple versions ago, and it's really the best place to go now for graphing, not just for creating graphics that you want to show, but for exploratory visualization. And by exploratory visualization, I mean visualizations where you want to get a sense of the data, see what's really happening, and sort of generate hypotheses. And so very quickly, it's built around drop zones. And the idea here being that you can try out or profile different visuals or different columns at will. And so let's actually start with our sort of main category distinguishing. So source table here. And I'll drag that to the X. And the first thing a JMP will do is it's simply going to cluster the points all in a point cloud. Now that may seem a little strange, but it turns out that that's actually sometimes very useful. In fact, the point clouds are useful, especially when we're looking at categorical distinctions. For instance, I could take that home type column, home type 2, remember that's the one we recoded, drag it to the Y, and very quickly we can see where we have observations. We have, for most of them, observations everywhere. The vacant land we only found in Brooklyn, and multifamily we only found in Chicago. And so what's very nice about this, and we're still adhering to our coloring, right? So since our colors are in the data set, let me actually go back to rows, and I'm going to clear row states. And just so we can see the point clouds more clearly here, it gives us a nice little sense of where observations are. Now, one thing that's great about Graph Builder is as soon as you drag observations into these different roles, you actually get really different visuals on the top that allows you to decide how you want to display this. And Graph Builder will be very specific. It's only going to give you the options that really make most sense given the types of variables you specified. And so when we have 2 categorical variables, this heat map becomes very useful. If I click this on, notice it gives us a little heat map of counts. So the darker meaning we have more observations in those sections. But you can probably see that just the points alone gives us a nice little representation of this. And so especially when you're looking at what type of data you have and what crosses you have or observations that are available in your data set, this is a nice way to do it. All right, so let me start over though. And I'm going to drag in source table again to my X. But this time, let's take one of our sort of main outcome variables. So how about list price? So I'll drag that into the Y. Now, when we do this, we still maintain the point clouds, but now this is something where most people would probably want to display a bar chart, just to give it a simpler representation. And so I'll click on the bars, and we get Brooklyn, Chicago, and San Francisco. Notice on the left, we get some options for how we want to control these bars. So we can decide what summary statistic we have, whether we have error bars on them, whether we put labels, so we can label by the values, sometimes a useful thing to do. Now what we get in this output though is a lot of other options. So group X, group Y, wrapping. These are all ways of breaking up these observations by different columns. And so let's actually go back to that home type option, because maybe we want to look at these bars separately for different types of homes. You know, the condos, the single family residences. I would probably want to tell my boss, you know, where the differences are really most big. And so let's take home type, and I'm not going to drop it yet. I'm just going to drag it to different sections so you see what happens. If I go to the group X, what we'll actually get is separate sections comparing the homes. And there's kind of a pop-out effect here. So for condos and for multifamily, it goes Brooklyn, Chicago, San Francisco for expense. Once we get to single-family residences, it's Brooklyn definitely higher in Chicago and then lower again in San Francisco. So that's kind of interesting. Let me go to group for Y so you can see what that looks like. This is a good example of a bad visual. This tells very little to me. Of course, it's the same data, but where the observations are, it makes it harder to see that pop-out effect. Just so you can see what wrapping does, wrapping goes left to right. Still does a nice job for that pop-out effect. And then overlay will put the bars right next to each other. And so this is probably most useful if what you're really wanting to show is within each city how those different areas relate in terms of their types of homes, rather relate in their average price. And so a really nice way to visualize this. I kind of like the group for X. That's pretty much my favorite. Now I want you to see something kind of useful here. When you're working in Graph Builder, and this is something you may not have done before, you can always layer visuals. When I click between visuals, so if I click on the outlier box plots, right, it changes them. If I click back to bars, it goes back. If I click and drag bars in again, I can actually stack or add the same thing into the data set or into the visual. And I want you to see why I might want to do this. So when we display list price, I often think about the median as a better example because these distributions are so skewed. So what we might want to do is let me keep the bar on the top, the mean, and the second bar, I'm going to make the median. And because these are always skewed to the right, we always have, the mean higher than the median here, we can get a kind of cool stacked bar where the median is showed with the mean. And it gives us a sense, a little bit, of the distribution of these because, when there's a really big difference between the mean and the median, that's almost always influenced by very huge houses. And you get something kind of interesting here. In San Francisco and Brooklyn, the medians are the same, but the means are different. And so that's kind of an interesting way to show this. And so with Graph Builder, know that you can layer different visuals. And perhaps my most favorite way to do this, let me show you, is what I normally do is turn on the points. So I just drag those in. I make the summary statistic for the points to be the mean or the median, whatever you like. Sometimes I like to give it an error bar, so the standard error. This is a nice way to do it. And then what I do is I drag in something known as the contour or the violin. And what the violin is a representation of really the point spreads. And so these violins are fattest or wider where the most points are. And so what you get really nicely is, without a lot of density on the page, so we don't have to see all the points, we get a sense of where the fattest part or where most of the distribution is. And so you can see that Brooklyn is really squanched down there, San Francisco is pretty dragged out, and Chicago's, very spread out. But we can still see where the means are. And this is a nice way to represent a lot of dimensions of the data. And so know that that contour is there, and know that you can add visuals on top of other visuals. And certainly attend the Graph Builder webinar because that's there's a lot of power in Graph Builder. Whenever you're done, just click done, and this is something we could actually show. All right, so I know that was a rather quick demonstration of Graph Builder, but Gail, do you have any questions or general questions too? I know we only have a couple minutes left, and I definitely want to get to those.
You're getting some questions that may be a little bit too much detail to cover now, but I will after you run the random number generator for those books. If we have time, I will read at least one of them to you. But let's see how many people are on. And again, we're giving away 2 copies to 2 people. So one for that person and one for a colleague of a basic Jump Essentials book. We have 225 people on, Julian. And if you would run that random integer.
There we go. So winner 1 was 99.
Number 40.
And 40.
Oh, I'm sorry. 99 and 40, thank you. Let me write that down before I forget. And I'm going to sort by first name, and I'll email those people afterwards. I probably won't have time to do it if we want to get to the questions. Can you add a column filter in Graph Builder?
Absolutely. So this is a great place to look under that script menu. And so you can do a local data filter here as well. And just like we did before, we can actually grab that outlier section, and we can click on the 1s or the 0s. Now, I want you to see also, under the script, we can do multiple things. So let's stack those 2 things we did before, a local data filter and a column switcher. And when you invoke a column switcher in Graph Builder, we can switch out, let's say, list price with our other main dependent variables. So list price, bedrooms, bathrooms, and square footage. And so now in one little panel, this is something that, especially if we have the visual setup that we like, we could take to our boss and actually click through all of this in one window. So without ever having to go back and forth.
And Julian, I will send everybody a link about how to export graphs to PowerPoint and JPEG, etc. We got a lot of questions on that, and we really don't have time to go into that today, but it's relatively straightforward. Let's see if there's another quick question I can get you to answer. Oh, this is perhaps a good way to talk about right-clicking being your friend. Somebody wants the lines, different colors in a graph builder, and some dotted and some, different format. Can you talk a little bit about how you can change the appearance of graphs in general? And we usually say right-click is your friend, so
that's right.
Maybe
right-click.
You can go over that.
You almost always get options here. So customize is a way to dig into some of the specific lines and marker sections, but almost always the place you'll want to go if you're in a graph is double-click the axis. So if you double-click the axis, you get all the axis settings. This is where I may want to make it log and put in grid lines or change the line colors or the increment widths. The same thing is true for the x-axis. If you click, you'll get all the options that apply to that axis. So almost always double-click an axis or right-click the plot and customize. Also under graph, when you right-click, this is where you get all your marker settings. So you're making the markers a different size. If you have longitude and latitudes, you can give it a background map, changing the width scales. Those are all available right in there.